Okay, let's start. Welcome, everybody. I'm Frederik de Rose from Combine, part of the AMR Accelerator. I will give a little welcome. We have, I think, a very interesting workshop coming up with wonderful speakers, excellent speakers. So we basically going to talk about how AI-powered search engines like Gemini, like ChatGPT are changing actually the way we think about digital result dissemination. So that's the overall theme. So in this workshop, it will be a little bit technical, it will be practical, there will be examples. I hope you find it very useful. It will also be interactive. So in this workshop, we will provide a general introduction to accessibility of digital content. We have three speakers. We first have Josephine Ferno, who is from Uppsala University. And Josephine will talk about accessibility. Then our invited speaker, Bishop Poccarel, from the Fraunhofer Institute, will guide us through the little bit more technical aspects. And then our colleague Tolga from Biocom will explain the efforts that are on the way to adapt the AMR Accelerator website to the new reality. So, Josephine, the floor is yours. Welcome.
Thank you. So we'll be talking about new opportunities, but also the challenges, and then figure out how to solve it. So AI tools, more people are using them, and we're asking ChatGPT to explain and find information. And then the large language learning models work in a different way than traditional search engines. And it makes it difficult for us to visualize what this looks like behind the scenes. So what we want to talk about today is machine-readable formats and how we structure information. So what it means is that accessible information helps both people and AI, and a lot of us are from public institutions. We need to comply with the European Union's Web Accessibility Directive that demands that all of our websites are accessible to anyone and providing equal access to people with permanent, temporary, or situational disabilities. And that's everything from using your phone, so you need to have something that adapts in size. You need a screen reader or caption video or keyboard navigation for different reasons. So when we make text machine readable, that means it's compatible with any kind of assistive technology, so text-to-speech or anything that helps us search and navigate. Screen readers, people with visual impairments might need to use the tab key to move around on the screen. It means we can convert into different formats. So text can become audio. People can listen to web pages as podcasts. We can edit and use content on the internet for large-scale data mining and research. And then if we make machine-readable text, it means we comply with these digital accessibility requirements. Plus, if we provide information with clear and logical structures, search engines and AI will be able to index information and then feed it back to those LLMs that help us search. So it means that information has to be perceivable, and images and video and audio content is not text-based, so it's not perceivable in this way. It means we need to be adaptable and make sure that content is distinguishable for people and for AI. So closed captions, we need to describe images, transcribe audio. And then if you imagine a nice graph where you present scientific results, that's an image, and AI or someone with a visual impairment are not able to interpret that. So we need to provide the data somehow in text or in numbers. And then if you have visual content, so colors need to work for colorblind and enough contrast, but that's not enough for AI. So if we want to make something accessible for people and machines, it needs to be text. So with clear structures, links and headings, we need to have descriptions of all of the sort of visual content. And then we need to make sure that people can actually understand it as well, and that links work in screen readers. So if you think of people, dyslexia affects a large portion of the population, and around 8% of all of the men in the population are colorblind. So the question is how we make images and figures accessible for them. And that's the key to making sort of understanding how an LLM will see content on the internet. So if you look at this green on red, a lot of us can read that. But if you're colorblind, you're not able to see the contrast. And for images, it's fairly simple. This is from another IMI project, a graphic. where this is taken into account. So you can see the contrast even if you're colorblind. However, that doesn't mean that an AI can interpret the information on this image. So it affects how we present information. So LLMs and traditional search engines are processing language, so text, and we need to make sure that we structure information in a way that machines can read and then quote unquote understand. And then we also need to write in ways that can be read and processed. So when you think about links in text, a lot of us do these kind of read more. And what we see in a text is a description with a link for video in this case, but a screen reader will often read this at the end, or they only see video. So it affects the way we structure content as well. So what we see in this case is links in the content bearing part of a page. So watch a video about cooking in 18th century America, and then it's very easy for us to see what's behind the link. And that will also help when it comes to gaming search engines. And we do a lot of content also. We develop digital information in PowerPoints that often are not using this kind of structured code. So this is an example of a poster. So from PowerPoint or InDesign, it's not formatted with headings. And what looks like headings is basically only larger bold font. And what it means is that a screen reader will see this as a big chunk of text and it's tricky to navigate. But we can make it machine readable if we use another space. So when we turn this kind of information into HTML, so traditional web page formatting, we can use this kind of heading structure, and then we can also add metadata. In this case, this is from the Zenodo platform, and it makes it easy to read because it's language in this case. But we often have on posters specifically, there's graphics and images, and that can still not be interpreted. So it needs to be translated into text. So I'm going to hand over to you now, Bishab.
Thank you, Josephine. We heard about the human readability part quite a lot. Now let's get a little bit in depth with machine readability here. How do large language models work? Taking an example of a simple autocorrect that's in your keypad or in Google keyboard, where you write a word and then the next word appears, follows. The classical large language models work like that. They are the text predictors, and how they work is, imagine there's a huge 2D vector space with different words. Here is an example of one. Let's assume there are words like king, man, and woman. And these all three words are in a 2D space, meaning they have a certain coordinate. If we find the distance between king and man, let's call it royal. And now if we add the distance to this point, woman, then we reach a certain point. Semantically, that's queen. So it brings this semantic meaning into the real world, right? How 2 points disguised as words have a certain distance, and if we add that distance to another word, then we reach to another word which is somehow similar. King and queen is similar to man and woman. So this is a very layman example of how the engine or the brain of language model work. So the right side is just an example of how the autocorrect also happens. So this is the mere beginning, so to say, of language models, and the advanced versions of these are ChatGPT and Gemini and so on. Now, this was very necessary to know how language model work, because we are now moving towards the availability of our content within these AI platforms. The modern day LLMs are not just doing the next word prediction, but they are doing Google search and whatnot, and they are termed as retrieval augmented generation. They retrieve the information from different sources, they augment, they perform some analysis, and then they generate language or information in their own words. So they are classical LLMs, something that we just saw right now, plus the information from reference knowledge base, meaning they also perform next word prediction to an advanced level, and they also do some Google search, bring that information out, add that to a knowledge base. They read internet forums, look at their comments, bring that information out, and also add that to the knowledge base, and then make up the answer to whatever we are searching for. So classical Google search would not really do that. It would just look and then find the correct page through the indexing and then bring that information. But now we are moving a little bit more wiser domain here. If we are to talk about the inherited engine of large language models, then this is what it looks like. Imagine you are putting a query, it retrieves the mathematical embeddings of that query. Sorry if I'm too technical here, and it compares it with the knowledge base. So if you need to understand what a large language model basically is a collection of a knowledge pool, right? We train a machine learning model with a lot of text, and then the knowledge inherited in that knowledge base or in that model is now, let's call it frozen knowledge base. If you are searching something there, then it can find what it has already learned. Plus, it can now search and find the information out of Google or any search platforms, also the internet forums, merge that up, let's say make a big list, and now performs ranking on which one could be the most suitable answer to your query, and then generates it in its own word and then respond it. Now you might see that everything here is textual. Please remember that, because that is going to be a big bottleneck afterwards. The simple Google search before the ChatGPT era would do something like you search something, it looked for the page numbers. Imagine this as a book with different page numbers. So you search for something in the Google, it looks for the right page number and then brings that page. No reconstruction of the answer, no analysis and whatnot, right? It was just just like mapping what you are searching for compared to this here. Now, it might seem like if you are searching something in ChatGPT, then it's adding the knowledge plus it's doing a Google search. Then what's wrong here? Like, it is one might consider this as just an updated version of Google search. But the problem is everything that we do here is text dependent. And like Josephine talked about how different formats of text in internet will affect the output, it's the same way for machines as well. The inavailability of text in images or probably in web pages affect a lot during the processing of the large language model answers. If something is not there, let's say there's an image without captions, then language model cannot see the information about the image. It's completely lost. And so is the situation with PDFs. They are generating answers based on what they can read, and they can just read text. Now, in the world of search engine optimization, or in the world of making our product visible to the public, how can we tackle this problem? We have to focus on what these language models can actually see in the internet. First, they can see very nicely about a table, a structured table that has hundreds of different columns and rows and so on. they can read it well. Something that you can control A and control V, the copy and paste, the typical copy paste works. If it works on your machine, then it's readable by the language model. Scanned PDFs, they cannot be converted into text easily. Therefore, the contents are not visible to the language models. They are ignored. Keywords, tags, captions, like we talked, abstract summaries, and citations mainly are focused by language models. Tags like H1, H2, if you are writing in HTML, are also focused. And images are not to a big extent parsable. So as of now. So something called search engine optimization is now going towards generative AI. Therefore, we call it generative engine optimization. I have put a little bit of information on how to transition from SEO to the GEO. First things first, we have to make our content as much visible as possible in the internet. Just an example of Grok here, it relies heavily on Twitter information, or just consider any other machine learning or LLM. If you go to Wikipedia and then probably find their own version of LLM, then it's highly likely that the Wikipedia LLM is mostly trained on Wikipedia data. That means if we do not put our information in Wikipedia, then the information is completely lost about the thing that we're trying to put there, right? So we need to be omnipresent in the internet is the key idea here. LLMs mostly rely on Reddit, Wikipedia, LinkedIn threads. Here's the 2025 example of where AI gets its info. It's from Statista, and it tells that Reddit forums are something that large language models like ChatGPT and Gemini really love, and they just go through the question answers there to give you the right answer. So provide your information about any article, any content, any paper in Reddit or Wikipedia and YouTube comments and so on. Likewise, there's a certain pattern hidden behind the writing approach of AI. You remember M dash, or probably using something like the word delve. These words are something that these language models use quite a lot. So if we make language models write content about our product and then put that in internet, then it's highly likely that that exact answer will be picked up and then shown to the public. So the next time when someone looks for what's ABC, then it will find its own answer there. And that's one way to trick AI to bring our content to the public and make the content visible under the own ecosystem. So what's also being done is that, let's say there's a plumber who wants to make the job visible to the internet, but they have not registered themselves in Google Business. Now, someone who is searching Google Gemini might not find the information right away, because Google, they try to emphasize the services from their own ecosystem. So someone who has registered themselves in Google Business might be more prioritized to the users of Gemini. So that's also another problem, so to say, or the way with which we can, bring our content out in this GEO era. Yeah. Another is to compare our approaches to the existing approaches. This is found that these language models really love to compare. So if we are writing a PACE or research paper, then probably related works section is a must or highly favorable. Backlinks building. So we write our content, we write a LinkedIn post, and then put that link in another post and kind of develop a backlink between every content or article we provide in the internet about our product, making use of tags like what this means. So there's something called named entity recognition in LLM world, which is heavily used and which is like a very basic skeleton of how language models function. So they break down entire sentence into subject, predicate, and object, and then perform processing on the top of that. So if we are providing like very generic information about what these are, I've given a simple example to explain. So if we are explaining something in a paragraph, then we would be it would be nice to write what these things are so that it will be easy for them, for AI to pick up and then show to the next person. And lastly, the original content should be in the target language. Let's say you are doing or searching something in ChatGPT in German, but the content is in English. Then yeah, ChatGPT can do very nice translation, but in the hindsight, what it tries to find is the English citations. So it does not do it in German. So that might be a big hurdle in finding the right information. So if we are trying to focus a German speaking audience, then it's very nice, very important that we provide information in German. And including frequently asked questions to the content is something similar to these Reddit forums. They really love question answering approaches. So anything that has something along the line of question answering, then it's nice to put in our content. Yeah, a small takeaway. SEO fundamentals, if you really know search engine optimization, then whatever we do still apply to generative engine optimization, because we are also doing, the AI is also doing search engine, bringing the search engine information back to its feeding pipeline, right? But yeah, now how Google searches is completely on SEO, because there's no analysis, there's no, bringing their own kind of information out to the public. Now we are moving towards how AI thinks and not just how Google crawls or how Google searches, which means that over time we might need to be embedding our information into the available books and resources, because 2 years from down the line, what happens is if the information are not available in books or research papers about our company or our product, then it's very less likely that AI will find it, because no matter how big this SEO part is going, AI is a static, it learns from the frozen knowledge base. So let's say there's a new company, it started today, or there's a new machine learning model, it came like a month ago. If it is not cited properly, if it is not available in the books, then the machine learning models that are regularly updated every year or so, the information will be very less in their knowledge. Meaning, if we put a lot of information of our machine learning model, and if it is cited by many research papers, then the next model, the new version, let's say GPT-6, might have more probability that our information is fed into its knowledge base. And yeah, the ChatGPT search is knowledge base learning plus Google search. Yeah, that's all from my side. Thank you.
Okay, so just to say something about how we can learn from fair data principles. So metadata is everywhere. So when we disseminate digital information, we can use descriptive titles and headings and synonyms in your text, clear headings and links that explain what's behind the links, and keywords can be used in different ways. So on Zenodo, if we use correct keywords and use this sort of already indexed ones, we can make results discoverable. And then if we include those same words in narrative text and alt text of images and hashtags in social media, it really helps us become discoverable. And that relates to search engine optimization. So with traditional SEO, we should just think about keywords in the text based on what your audience is likely to search for, and synonyms, because we might have several target audiences. So a professional might search for medicines, and the general public might search for drugs, for example. And repeat the same words of the heading in the first paragraph, just making sure that we're not using more poetic titles, and that it matches, because Google will take a look at the heading and then check whether the text on the page is actually about the thing that the heading claims it's about, because it's a classic way of trying to get spam content onto people's searches. So it will be discriminated against. Describe all of your images in text that's related to the image, either on the page or in the sort of metadata behind. Structure content. So in Word, you have the kind of structuring where you can use headings, heading 1, 2, 3, and 4, and if you make proper lists instead of making them visually appealing, it also helps to navigate the text, both for people and for LLMs and traditional, and Google as well. And then if you have good readability, so short sentences, short words, that also helps for search engine optimization. The more popular the language seems, the more likely it's going to be picked up, the less expert it looks. And then it should be mobile friendly, which means it's adaptable. So you have something on a big screen, and when you turn that onto a small screen, it can still be understood and read and looked at. And then you need to update your pages once in a while to make sure that Google still believes it's relevant. Because if it's something that was, even if it's static content that doesn't change, if the page was updated in 2018 and now we're in 2025, it's going to look like it's not very important. So, Tolga, you want to take over?
Thank you, Josephine, and thank you, Bishop, for introducing the topic of how exactly LLMs work. And if we now all understand that we don't need to throw out the traditional SEO techniques out of the window. They are still relevant, but we now need to adapt them, what we do, to this so-called generative engine optimization. So we still need to structure digital waste just in a new way. And one of those key considerations is to respond to the conversational queries. So essentially, we need to make sure that we answer the questions that our end users might ask ChatGPT or Gemini. Basically, we need to predict what kind of questions and what kind of answers can lead our audience to our website. And I will come back to that a bit later, because there is also the consideration that is a bit difficult. We need to make sure that our content is readable for machines and that it essentially feeds usable and understandable chunks of the content to the ChatGPT, to the AIs, so they could regurgitate this into the answer that users are looking for. We need to interlink all of our content with the descriptive anchor text, just like Josephine has already shown us. And essentially, we just need to rethink website structure in general. Could you move to the next slide, please? Thank you. So we have already made some effort, and I have now summarized this in the 4 big important topics. So the conversational queries that we have just mentioned, the content readability. Also, what we have not talked about until now is that we need to ensure that why our website, why our content, why our information and our messaging should be prioritized when people are asking questions about AMR. And this is by showing our expertise and the trustworthiness. So, and the website structure, which we have already mentioned. Next slide, please. So I will right now focus on this 3 last considerations. Next. And we are starting by optimizing our web page to lead people from the landing page right into the results. So what is the most important outcome of the projects is the things that will stay there. It's the webinars, the tools and resources, the papers, of course, and the portfolio of the assets. So on this landing page, we are already mentioning the content readability in a sense of a summary of what AMR Accelerator program in general is, and we are already introducing the interlinking of the pages between each other to improve the website structure. Next one. Also, each page essentially has the summary of what that page contains. This isn't necessarily for people. This is more for AIs, because this description exactly shows people, shows the machine what is exactly on the page, and then that information could make sure that this page is offered as a reference whenever someone is looking, for example, on training in antimicrobial discovery, let's say, and they might find our public webinars, or they might look for tools or assay protocols for policymakers, right? And they might lead to our tools and resources page. Next one. So the next consideration, the expertise and trustworthiness, should be coming from next, ensuring that the papers that we are listing on our resources, on our catalogs, have the DOI links. So not the link to the website of the journal, but the static DOI link. And this will ensure that, that our website is a trustworthy resource because it has links to the peer-reviewed scientific publications. Next one. This is also showing that our expertise is showing the human face behind the research. So the scientists, these are the people who can be trusted on AMR topics because they have the credentials for it and they are connected to our projects. So this is why interviews with the scientists on our website is an essential way to show why people should be trusting AMR Accelerator content. In comparison to, let's say, other projects. Hopefully they're also trustworthy though. Next slide, please. And also ensuring that our resources are also available on public repositories that will be maintained for a long time, such as Zenodo, is another way of showing why we can be trusted and why our content is important to be maintained for a longer period of time. So essentially, next slide. I have now talked about what exactly in practice you can do to ensure that your content is picked up by LLMs, by AI-powered search engines. So ensure the content readability, the expertise, and trustworthiness. Update the website structure, use public repositories such as Zenodo. And one thing that we really need the help, and this is the consideration that I was talking in the beginning, the conversational queries. We might not know how exactly a data researcher will be looking for tools that is designed for data scientists. So this is why the conversational part of how exactly people are looking for the tools, this is where we need the crowd help, so to say. But I will let Josephine to continue with that, so please take away.
Yes, so the question is how we can make this work. And we wanted to use a UX, user experience persona approach. So we have fictive but realistic actual users of our content. And what we do normally is we look at much information that we can find about them, and that person or persona has objectives and needs and motivations and behaviors. So what we want to do is to connect that to our product, and what we've sort of thought about is the tools and resources webpage, like the collection of everything that's come out of the AMR Accelerator project. And if we use this approach, it helps us understand the end users and helps guide design and readability decisions But today we've focused more on the sort of technical needs of these people. And then so we've divided this into 2 workshops. So today we talk about technical needs, and the next time we hope you'll join then as well. We talk about information needs and motivations and behaviors. So if we think of ChatGPT, Gemini, Grok as people, another person who have the same kind of accessibility needs that people with different impairments have. So we have someone with dyslexia that uses a screen reader who inputs text via dictation, who needs text-to-speech, who's also part of our target audience. We have people who use mobile devices who need adaptable content that is legible on small screens and that can be used on the go. That's another kind of need that also requires machine-readable structured content. We have people who are colorblind that need good contrast and who need descriptions of images where they might not be able to read a color legend in a graph. And then we have people with visual impairments that need magnification, adaptable content, and good contrast. And the question is, what does ChatGPT need? What does Gemini and Grok need to make sure that they can access our information? Because we know a lot about people with impairments, but they use the same kind of machine-readable tools that LLMs do. So how can we adapt?